What is a quantum state vector in quantum circuits? Have you ever wondered how quantum computers manage to process information so differently from classical computers? One key concept that helps explain this is the quantum state vector. Let's break it down in a simple way. A quantum state vector is a mathematical tool used to describe the state of a quantum system, like the qubits in a quantum circuit. It is represented as a column vector in a special space called Hilbert space. This vector holds all the information needed to understand the system's condition at a specific moment, including the probabilities and phases of the qubit's possible states. To start with, think about a single qubit. It can be in a state represented by a two-dimensional quantum state vector. And like a classical bit, which can only be either 0 or 1, a qubit can exist in a superposition, meaning it can be a mix of both 0 and 1. The quantum state vector for one qubit is a two-element column vector with complex numbers. The sum of the squares of these numbers must equal 1, ensuring that the vector is a unit vector, which is necessary for a valid quantum state. For instance, the vectors 1, 0, and 0, 1 representing the two basis states, corresponding to the classical states 0 and 1. Now, when we move to multiple qubits in a quantum circuit, things get interesting. The quantum state vector expands exponentially. For n qubits, the state vector has to raise to the power of n complex components. Each of these components represents the amplitude of a specific basis state of the system. This vector captures the probabilities of measuring the system in any of its possible configurations, along with the relative phases that influence interference and entanglement. As we apply quantum gates in a quantum circuit, the quantum state vector evolves. Each gate corresponds to a unitary operation represented by a matrix that modifies the state vector, changing its components according to the principles of quantum mechanics. This evolution is what allows quantum circuits to perform complex calculations by manipulating the quantum state vector through sequences of gates. Understanding quantum state vectors is essential for designing and analyzing quantum circuits. Many software tools representing quantum states using these vectors, enabling developers to track how quantum algorithms transform the system from an initial state, often the all-zero state, to a final state that encodes the solution to a problem. In essence, the quantum state vector is the fundamental descriptor of a quantum system's state within quantum circuits. It captures all the quantum information, evolves through gate operations, and enables the unique computational capabilities of quantum technology.